Hello everyone, I'm Xiaohua. Welcome to the meeting. Today I will talk about the MetaVerse Painter, the Tersus MVP product line. The global market for 3D mapping is huge. That's why Tersus are offering the LiDAR payload solution MVP, because we see a lot of applications like topography, survey, and mapping, stockpile volume measurement, utility inspections, the digital twin, and lots of applications are just emerging. There are two kinds of laser 3D scanner for surveying. One is a terrestrial 3D scanner. They are stationary. They use the laser pulse to measure the range, and usually they are auto-leveling and can offer less than 1 centimeter accuracy. The price tag is from 10K to 100K US dollar. And another category is a mobile mapping system. Because it's mobile, so it can be mounted on the car or airplane, or can be handheld. They use the laser pulse to measure the range with the centimeter accuracy, and plus GNSS, GPS for sync. And also use a SLAM and IMU and DMI to compensate the outage of the GNSS signal. And it offers mobility and flexibility and speed. And it can be directly adjusted with the local coordinate system because of the GNSS. And the price tag is 10K to 1 million US dollar. Why the price is so different? You can learn from this presentation. And the accuracy is like 10 centimeter to 1 centimeter accuracy. So the mobile can be car, can be drone and cart, and backpack and plane. As the market matures, the competition is intensifying. You can see 10, maybe 20 companies are offering the LiDAR payload. But if we divide the 4 categories, all about performance, it's about accuracy, it's about the user experience. The workflow is streamlined or not, it's high efficiency or not, and the cost, because every survey job should be done costly. And the branding. I think the most important of the branding is like trustworthy and the support, because mobile mapping system will be very complicated. It requires lots of knowledge to understand. Otherwise, it's useless. So why choose the Tersus MVP? Tersus MVP is developed and manufactured by a trustworthy company with 10 years of experience providing GNSS, IMU, visual, SLAM to the most demanding customers. Here is a testimony from a customer. He is also a PRS. I have to say I'm still super impressed with absolute accuracy of the Tersus MVP with no adjustment. I woke up this morning and ran the L1 data through the same checks and getting a analysis from 3.67 centimeter in height. But the Tersus MVP I'm getting is 1 centimeter accuracy. I gave L1 the best possible chance, run optimization in TerraSolid, and adjust to the GCP using the mean offset in TerraScan and kept the data in WGS84. But Tersus MVP, I don't do anything extra. It actually makes the Tersus MVP workflow better with 3 times better accuracy on a simple project. So it's all about accuracy. You can get L1 at 15K US dollar, but you can't get the accuracy of centimeter accuracy. The Tersus MVP support best-in-class performance because of our POS system, our INS system, and the software. So in the right, in the left, you can see the system, how we build a system. We use the gyro, accelerometer, calibrations, and the IMU, genesis, and the laser and the camera. We build the whole system together. And then in the right, you can see how you can operate the software and the hardware. So it's really complicated, for end user. It requires lots of energy and knowledge. And you can see from all the system together, you can see the POS specs for the roll, pitch, and heading. From Tersus MVP, it's like 0.006 degree roll and pitch. In the heading, it's like 0.03 degree. But the competitors are larger. And the Tersus MVP can support lots of LiDAR from commercial like Berkshire, like DJI, like Regal, and Vanadai. And also it can support 1 terabyte USB driver. And the above ground level is up to 200 meters. It is because it's limited by the LiDAR scanner. And also it can attach a USB camera interface. And the Wi-Fi is embedded Wi-Fi. We can configure through the Wi-Fi system. You can attach a GSM or 4G modem because sometimes you need the RTK result immediately. But sometimes, most of the time, you don't need any GSM and 4G because we do the PPK without any RTK result. And the point cloud accuracy is like 3 to 5 centimeters, depending on the conditions. And without LiDAR, the power consumption is 4 watts. This is a typical use case by the Tersus MVP. And Tersus MVP is more than a drone LiDAR payload. It can be done lots of applications in vehicle or handheld, in the mobile condition. And we can see the Tersus solution is what we are offering. It's like a GNSS board from Tersus, BX40C, and there is a GNSS system provide the PPS sync to the LiDAR, to the camera, and also we use the IMU to provide the accelerometer and the gyroscope to the INS system. And the INS also provide the attitude to the payload computer with the positioning and the velocity. And this payload computer will output a file into the processing software. In this software running in the computer, we can output the less file. That's the Tersus output. Then you can input less file into Telesolid, Global Map, Bentley CC, or Cloud Compare to do the power cloud processing. And you can, from there, you can output the DEM and DSM. Here is a quick study about the mobile MVP system, because in urban area it's more challenging than in the air. So I showcase a typical urban area. This is done in Australia, Melbourne. So typical urban area sometimes is only have 4 satellites for the RTK system. So it's very challenging. So outage, the GNSS outage could be 10 seconds. And the accuracy is less than 3 centimeter. Because we have the best INS software in the industry, so we can do the outage in the 10 seconds. And the Tersus value proposition is accuracy is everything. So here is a report of the trajectory general report. So you can see the green line is the rover IMU data, and the red line is the rover GNSS raw data, and the base is the GNSS base station data. So from this diagram, you can see the base stations cover the IMU and the GNSS. So you need a very good base station to output raw measurement and other data. And from the rover, you can't miss 1 second. Otherwise, the rover will not be good accuracy. Now here is a diagram showing what we achieved in the urban area, because lots of buildings, trees. So sometimes the total GNSS we use less than here is a 6, right? And sometimes RTK couldn't be fixed in those period. That's the mobile map system difference in the land compared to the air. If you're in air, you have all the signals continuously tracking. But in the land, in the urban area, you have the signals bounce like this. In this test, we have the full constellations: GPS, GLONASS, Galileo, Beidou, and QZSS. You can see all the signals are tracking. And also you can see the GPS position quality is not good enough in some area. But we have the IMU, we have the INS system, so we can do GNSS and IMU fusion to mitigate the errors. So our system can mitigate 10 seconds. So in this period, it's like 10 seconds. So the whole data should be fine. In this way, we can do the level arm refining, and you can just leave the system to calculate the level arm. And this is a very good indicating of your system, how it's performing, because we have the attitude separation, we have the reverse and forward, we have the test all the system with 0.7 arc mean. In our practice, less than 4 arc mean is very good accuracy. So this case should be fine. So At the end, we produce cloud and output in the cloud compare. Now we can verify the local coordinates with the GDA 2020. It's less than 3 centimeter accuracy. So now we can do a summary for the Tersus MVP advantages. First is a tactical grade RMU. Compared to the DJI to other competitors, they use a consumer grade RMU. So our RMU is very expensive and tactical grade. And also we can do the RTK and the PPK solutions. And the SLAM compatible because we will use our MVP in the handheld or backplane. Then there is no GNSS because there are sometimes it's indoor. So we use the SLAM. It's SLAM compatible, but it's not released yet. And it's a one button operation. You just push a button and fly. And I just say the antenna level arm offset estimation. So the software will calculate the level arm offset. And if you use the Hersey XT32, you can get 3 centimeter accuracy in the urban area. And we can do the batch processing. So lots of project can be batch processed. And we use the Tersus in-house software to do the post-processing. And we use the Tersus OEM board. And also, with the factory, we do the full bore sight and calibration tools. So that's today's presentation. Thank you very much.